Hello ladies and gentlemen, what's up? It's Papa Bale and welcome to the channel. So when I posted first about my permanent magnet experiment, I didn't have this much permanent magnets in there, but now you see where I'm getting lost as to why, there's not more drag on the rotor or the stator here. The outer ring. Alright, so let's give it a little nudge. See, like no problem whatsoever. Actually, it looks like it's helping it move, doesn't it? Look at that. I mean, it should. And here, let me just show you. We got a north and a south face, and all the magnets in the middle are facing one, or on the side here are facing one way. So you got a south, you got a north, and then all the magnets here are facing southward in. Okay, so this is north, this is south, all these south in. So watch this. Raise that up. Yeah, see, no hindrance. That's what I'm getting at. There's obviously a south and a north that are running into each other here, and it's not slowing it down. I think that's awesome. But it is, more friction than if it wasn't there at all. But you can get some definite motion from this. Maybe not increased motion, but all I'm getting at is that with all that magnetism in there, there should be a slight, problem with it spinning. In my mind, there should be some sort of break happening. But watch this. Yeah, now it likes it. Now it's stuck. Okay, let me find out which side of the magnet. See, I switch it and look at that. Now that's a break. So if you change any of the magnets from all facing the same way on the outer stator, you're going to have a problem. That's why I know this is unique and special. I mean, it's not, I don't see all this stuff. You can't do it. Perpetual motion. Okay, whatever. It's not perpetual motion, obviously. And just because I'm playing with permanent magnets doesn't mean I'm going for perpetual motion. Just leave me in peace. If I get perpetual motion, I'll let you know. But I'm not like looking for it, you know what I mean? I'm just looking for this thing to move a little bit. And I found a way that it moves like basically like if the magnets weren't in the middle at all. I think that's super cool. And I got my 8 magnet, it's 8 pegs, okay? Instead of 4 pegs like I usually have on my rotor, there's going to be 8. But there's going to be only room for one coil. I'm going to be doing 32 gauge and 26 gauge bifilers around the whole thing. We're gonna do, if it's gonna happen at all, it's gonna happen with this for sure. And it doesn't matter if it happens. For it to go, like if I start it up thinking it's gonna stop and just let it go all night, wake up and it's still moving. Now that I'd like that. That would be cool. Now, see, with the Neos in there, the extra Neos, you get a nice kick. Nice cogging. But you see now it'll stop at that one unless you give it that two hump clearance. So like 1, 2. And then once you give it 2 hump clearance, it's going to spin for like 10 minutes. So I mean, 2 humps is a magnet. You saw when it like stopped, that's a hump. Wherever it likes to stop, that's what your hump is, and you have to cross over that 2 times to get it to continue to spin at a significant pace and rate. Because if you just knock it over that first hump, it's going to stop at the first hump. That's the rule. That's how it happens. Unless you've negated the magnetism somehow, it's going to happen. So that's why you got to push it over that one more time. So like 1, 2 magnets. I'm like, how in the hell is this happening? Because when I tried to put the magnet back in the hole, it was like, nah, man, if I let this go, we're going to have a fireworks show. And sparks are going to go everywhere because there's so much magnetism in there right now that, you know, I was kind of like nervous. Like, oh man, that's strong. This reminds me of when I was doing my motor in the other room, my permanent magnet. I had donut toroids circling the whole rotor, and it would bounce like this, just like this. I'm like, it really wants to move. And then, you push it over the 2 humps. That rotor could move for a long time. Long time. Heck yeah, man, that rotor is bad. Good, bad in a good way, and I still got it, and it's sweet, but it's not a 10mm shaft, it's a 1/4 inch shaft. So I gotta rebuild my 1/4 inch table, and maybe I could use some of my old stuff. Yeah, man, I really like this. I think this is cool. I don't think it's what everybody, that's nothing. But it is. It truly is. It's something cool, something special. Let me explain to you the dynamics here. So this is a north-south configuration in the middle, right? This is all south. So when it passes the south side, it's pushing. When it passes the north side, it's pulling. At the same time, because there's those 180 magnets. So you got the 2 south, and one's pushing and one's pulling, all 3 times per rotation. Now, since I'm not dumb, I would never claim that this would move forever or that this is perpetual motion. I wouldn't claim that. It'd be awesome though if one day I just like got a configuration and I went like this and it spun for like 2 days. That'd be awesome, wouldn't it? Heck yeah, that'd be awesome. Like it would never happen awesome, but yeah, awesome. So I'm going to whip it now. You like these motors, the more momentum, the more action you get, longer period of action that you get, right? So I just spun it like that and we'll see what happens. See, but the real special thing about this whole thing is that look at it go. Look at the stator go, and there's the freaking magnet that could hold up the Empire State Building in the middle. I don't get it, but I'm pretty sure it has to do with exactly how I explained it being lined up with the south and the south and the south and the north, and having a push-pull simultaneous. Look at it go. So much magnetism in there. And yes, there's attraction happening in there. It's all happening in there. Like from the stator to the rotor, there is attraction on one of those sides. Like really strong attraction. So cool. All right, well, I feel like you guys kind of get the gist, and you get the point that I'm not trying to pull any wool over your eyes. And if you don't, then you don't know how to listen. All right, love you guys. Peace out. Have a great night. Bye now.